Welcome to the 86th lecture of Digital Electronics. Now in the coming lectures, that is lecture number 86, 87, 88 and 89, we will be dealing with the truth table and excitation table of flip-flops. In this lecture, we will be dealing with truth table and excitation table of set reset flip-flops, that is SR flip-flops. Now before going into the truth table and excitation table of SR flip-flops, let me go into the characteristic equation of SR flip-flop. Now, already it is already mentioned in the previous lectures. So here we are having present state. Present state is Qn, and next state is Qn plus 1. And the characteristic equation is derived as Qn plus 1 as a function of Qn, S and R. That is Qn plus 1 is S plus R bar Qn. Now, let me explain it one by one. Now what I am going to do is I am going to simplify this table. I am going to simplify this entire table. Okay, I want to simplify this entire table. That is my intention. Okay. Now, what is the characteristic equation? What we have? I am rewriting the characteristic equation of the SR flip-flop. The characteristic equation of SR flip-flop is Qn plus 1 is equal to S plus R bar Qn. S plus R bar Qn. Now let me draw the truth table of SR flip-flop. Truth table of SR flip-flop. Okay. So for SR flip-flop, the inputs are S and R. Okay. Assume that clock is equal to 1 and inputs are S and R, and the output is then a state, that is Qn plus 1. That is the next state. So I can have S and R is equal to 0, 0, 1, 1, 0 and 1, 1. Now see, when S and R is equal to 0, what is the condition? When S and R is equal to 0, what happens? Here Qn plus 1 becomes, okay, first case, Qn plus 1 becomes, when S is equal to 0, R is equal to 0. When S is equal to 0, R is equal to 0. What is Qn plus 1? Is equal to 0 or 0 bar Qn. That is, what is that? That is 0 or 1 dot Qn. So that is Qn itself. So you can write Qn plus 1 is equal to Qn. Now when S is equal to 0, R is equal to 1. That is, when S is equal to 0, R is equal to 1. What is the next case? We can write Qn plus 1 is equal to 0 or 1 bar Qn. So what is it? That is 0 or 0 dot Qn. What is it? That is 0 itself. So Qn plus 1 will be 0. Next case, S is equal to 1 and R is equal to 0. S is equal to 1 and R is equal to 0. So what is Qn plus 1? Qn plus 1 will be 1 or 0 bar Qn. What is it? That is 1 or Qn. 1 or Qn. What is it? It is always, yeah, it is 1 or Qn. What is it? That is always 1. So it is 1. So you can term it as set. So this is no change, or a previous state itself. This is previous state itself. This is reset. This is set. Now when S is equal to 1, R is equal to 1. That is the next question. When S is equal to 1 and R is equal to 1, what happens? See, here when S is equal to 1 and R is equal to 1, we cannot predict to which state it will go, right? So see, here S is equal to 1 and R is equal to 1, you can look to this line. When S is equal to 1 and R is equal to 1, if you look into this line, you cannot predict what is Qn plus 1. Here also when S is equal to 1 and R is equal to 1, you cannot predict to which line it will go. That means when S is equal to 1 and R is equal to 1, to Qn plus 1 is don't care. That is, it is invalid state. That is the invalid state. Okay. So that is regarding the truth table of SR flip-flop. Now coming into the excitation table. Coming into the excitation table of SR flip-flop. Excitation table of SR flip-flop. Okay. So what is basically excitation table? Excitation table means present state and next state will be given. present state and next state will be given. You need to find the values of S and R. Okay. Present state and next state will be given. You need to find the values of S and R. That is the excitation table. Okay. So I am drawing the excitation table. So I am having Qn. That is the present state. Qn plus 1, that is the next state. This is present state. This is next state. Now you need to find the values of S and R. Okay. So here there are different cases. Present state can be 0, next state can be 0. Present state can be 0, next state can be 1. Present state can be 1, next state can be 0. Present state is 1 and next state is also equal to 1. Now see, when present state is 0 and next state is 0, what is the condition? See, now coming into that. When present state is equal to 0 and next state is equal to 0, what is it? So you can take these two, right? Here present state is equal to 0 as well as next state is equal to 0. Okay, right, in these two conditions. Present state is equal to 0 and next state is equal to 0. So what we can have? S is 0 and R is don't care. Right? Because R can be 0 or 1. So R is don't care. So it is 0, don't care. Next case, present state is 0, next state is 1. You go back. Present state is 0, next state is 1. Okay. What is it? There is only one case. That is this case. Present state is 0 and next state is 1. That is only case here. So what is S and R? S and R is 1 and 0. S and R is 1 and 0. Now come to present state is 1 and next state is 0. What is it? Present state is 1 and next state is 0. That is only this case. Present state is 1 and next state is 0. Only this case is there. So what are the values of S and R? Values of S and R is 0 and 1. It is 0 and 1. Now present state and next state is 1. Present state and next state is 1. Is there any condition like that? Yeah. If present state and next state is 1. Okay. Is there any condition? Yeah. See, here present state is 1 as well as next state is 1. Okay, that is I will draw it another color. Here present state is 1 and next state is 1. Again here also what we have? Present state is 1 and next state is 1. Okay, only in these two conditions. Now see, here what happens? Here S can be 0 or 1 and R is always 0. Therefore what we can write? S is don't care and R is equal to 0. So S is don't care and R is equal to 0. Okay. So that is the excitation table of SR flip-flop. Hope you have understood the formation of excitation table and truth table of SR flip-flop. Okay. So that is regarding the truth table and excitation table. So initially I have taken the characteristic equation of SR flip-flop, and again if S and R is equal to 1, if you look into the characteristic equation, what happens? Qn plus 1 is S equal to, now see, if S is equal to 1 and R is equal to 1, if you are looking back to the characteristic equation, what will you get? Qn plus 1 is equal to 1 or 1 bar Qn. What is it? It can be 1 or 0 dot Qn. So that is 1. But actually what happens? Actually this is not the actual thing, because result is also equal to 1. Okay. So when S and R is equal to 1, you have to check for that condition. That means when S is equal to 1 and R is equal to 1, you can see that Qn plus 1 is don't care. Okay, so you have to go with such a condition. Okay, so that is regarding the truth table, and excitation table also I have derived from here. Okay, so that is all regarding this lecture. In the next lecture we will be dealing with truth table and excitation table of JK flip-flop. Thank you.